Hey, and welcome to the Software Tray. In this video series, we're going to build a super awesome website. And that super awesome website will have a login component. It'll have a messaging component where we can message multiple users. And it'll have a profile component where you can update the user's data. So in this super awesome website, we can take multiple users like you see here, and we can coordinate messages between them. So let's do that real quick. Here we can add test1 and test2, add a message, send it, and you'll see it'll be synchronized with this user, and with this user. And then they can communicate back and forth, and they'll continue to be synchronized amongst them. And we will show you how to do all of that using Angular, .NET, and SQL Server database. So let's discuss the architecture of our app. And it'll be constructed with Angular, the front-end client, Web API with C#, this is we using .NET Core, and a SQL Server database. And just to go over the flow of the process, our user here will ask the browser to connect to a web server. The web server will allow you to download the data to the browser. The browser will then have connections to the back-end APIs, each of them individually. And each of these APIs will have a connection to the database, and they will only be able to communicate with one another. And in this way, you'll be able to flow from the user all the way to the database and back to the user. So we're going to build a messaging service from scratch. We'll build a client, a server, and a database. And for our client, our goal is to build one code base that will run on any device with a similar look and feel. That way you build it once, run it everywhere. And we're going to do this with Angular 11 and Bootstrap 5 for our styling. We're going to build a server. It's going to use a microservice architecture. The code base is going to be portable. It can run on any device. And we're going to be using .NET Core 3.1. And our database is going to be a SQL Server database. We're going to be using an ORM framework, EntityFrameworkCore. And this is going to be a model-driven database design. Basically, we're going to build a set of models that's going to tell the database how it's structured. And as we said before, we're going to use SQL Server. So first up is the database. We'll build an authorization service using Microsoft's Identity Service to authenticate the user. We'll build a user database to store the user profile data in a separate instance. We'll build the messaging database to store all the messages in another instance. And we'll be able to tie all three of these together using the client, which will connect to each of the web APIs. So let's go over the SQL Server database. Let's get our database installed. So if we type SQL Server into Google, we grab the SQL Server download page from Microsoft. And let's scroll down till we get to the Developer Edition. We're going to go ahead and download that. And let's go ahead and run it. All right, so here we are ready to install SQL Server. Take the basic installation, accept the privacy agreement, go ahead and run the install. And this is going to take a while. And after it's done, we're going to install SQL Server Management Studio. All right, our SQL Server database is installed. Let's install the SQL Server Management Studio. So if we click here, we'll be directed to a download page here where we can download the SSMS service. And once this is done, we will fire it up and run through the prompts. All right, everything's now downloaded. Let's go ahead and install. All right, now that we're running, let's click Install. And this is going to take a second. It won't be as long as a SQL Server installation, but we're going to go ahead and let this run until completion. All right, now that the SQL Server Management Studio is installed, let's go ahead and run it. So now that it's fired up, we use Windows Authentication and just use the dot period in order to connect. And right here we have our database structure. We can create instances in this database folder, and we'll show you how to do that quickly. All right, now we want to get our web API set up. So let's go get .NET 5. So here we can go search .NET 5, go to download .NET 5.0. This looks a little confusing. You can grab the first runtime SDK here. You can click on this link here and grab the .NET SDK 64 edition. That'll give you the latest one. If it doesn't download, you can do this manually. So I've already downloaded this, so let me go ahead and pull that up. Go ahead and run the installer. Click install, yes, and let it run. It's going to take a second to get all this complete. All right, next up for our web API is Visual Studio 2019. So we're going to go ahead and grab that download here. We're going to grab the Community Edition since that's free, and we're going to let it download. And we're going to go ahead and run it. So let's go ahead and hit Continue. And we're going to go ahead and just click on this ASP.NET Web Development. That's all that we'll need. We have other options here. You can choose if you have to do something different. But for our needs, just for the ASP.NET Core, this is all that we're going to need to install. So this is going to take a little bit. So now that we've installed Visual Studio, we defaulted it to launch on installation. So the Visual Studio IDE has launched. You may have to log in or create an account with Microsoft or associate an existing email with Microsoft in order to get this working, but just understand it's all free. So once you get that done, you'll be on this window. And let's go ahead and click Create a New Project. And we're going to go to ASP.NET Core Web Application. So we're going to go ahead and click Next on that. We're going to give it a name, Messenger Service. And we're going to go ahead and put it in our D directory, right where we had the Angular project we created. And this will create a messenger service under the project folder directory. And the next step here, let's click API and do create. And this is going to create our project, and we'll get basically a shell project that we can start using in order to build more APIs, all of our database access, and our models. All right, first up, for building a database, we're going to need to build a set of models. So in order to start out, go ahead to your solution, right mouse click, add new project. Go down to C# class library. There's also a VB.NET, so make sure you're on C# unless you want to do everything in VB.NET. Click Next, name it Models, and then click Create. And that'll create this class library called Models. And we can add different folders by right mouse click, Add Folder, or we can add classes within those folders to segment things out. So we're going to have 3 different databases, a user database, a messenger database. We also have this base class that everything inherits, but we're also going to hook into Microsoft's identity user class. So we will have this model built for us already by Microsoft. So we are going to use this to build the identity service. So let's discuss the user database that we're going to build. It needs a user class, an image class, and a contact class. We also have a base class called HIDC that we're going to incorporate with all of these classes, or at least all the ones that are in the database. So for the user, the linking between the identity is with this authorization ID property. That'll tell you that this user is linked to whatever logged in user that you have. We can give that logged in user a name, a profile, a birth date, an image, and a list of contact information. So on the images, we just use a file to store a base 64 string that can be read on the front end and resolved to an image. Our contacts will use a simple string as a link, and then we can have a configurable set of types that we'll use, and we'll actually build these on the front end for email, home, and cell phone. And finally, the base class is our general housekeeping fields. This has the ID, which is your key. It has an is deleted and is disabled field, so we can toggle whether we want to delete this object or whether we want to disable this object. This will make it a little quicker to just update these fields on the front end as opposed to going through the server to delete them. We can always delete deleted objects that are flagged as true later on in a long-running process if we want to clean up our database. We want to determine when the object was created, when it was last updated, and we want to use this row version class for concurrency. And we determine concurrency by using this timestamp attribute. And this will give us a unique value every time we get an object from the database. Therefore, if we have an old timestamp, we won't be able to update that database. It's basically last in wins. And then we have these as all being required. So they must have some value set when you're inserting into the database in order for this to work. And we're also using date time offset. And that's a very important thing to do because this uses UTC time. And UTC time is universal. So if we have a universal time for the whole world, then we can configure the local time based upon JavaScript on the front end, determining what the local time is. So with that, we have our whole model for our user database set. So let's discuss our messaging database. So our messaging database at the top level has a pool object. A pool object has a list of members, which will store who is part of this pool. And it'll have a list of messages, basically all the messages in this pool. So our members are going to have an authorization ID, which will link the users to this pool. So the way that we're going to access which pools to grab is basically if you're a member of this pool, you're going to pull back that data for the pool. And then all of the messages will be listed here. We'll have the text string for the message, and we'll have a from auth, which will list the identifier of the logged in user, so we know which user sent this message. So a couple things to note on the models. You'll probably have to import some NuGet packages. So one of the ones that we'll have to do is the system component data annotations. If you don't have this here, let's say we got rid of it, you can always click on this object, do Control period. And if you can get this system component models.data annotations, then go ahead and add that. If not, go to the models class, right mouse click, manage NuGet packages. And if you type in data annotations, should be able to get it here. And we just need one that's compatible with Microsoft Framework 2.1. And if for any reason, you can always double check this. We can set our target framework. If it's set to 2.0, go ahead and set it to 2.1. So that'll be one thing that you'll need to add. The other thing that you may need to add over here is we are going to use this ignore data member attribute. And this comes from newtonsoft.json. So same thing here. Go to your NuGet packages and make sure that you have newtonsoft.json installed. And once again, it's compatible with 2.1. So those are some additions you may have to make to the user model, depending on what NuGet packages are currently installed. So check on that and add them if you need them. So next up, we're going to build a set of DB context classes. And these classes allow you to access an instance of a database and query its tables. So as the documents say here, a DB context instance represents a session with the database and can be used to query and save instances of your entities. So that's what we're going to build next. So next up is our DB context class. And we're going to create a library to segment all of our database objects from our models. So in order to do that, let's go to the Solutions Explorer, right mouse click, Add, New Project, go to Class Library, next, type in Dow, and then click Create. So this will create this class library here. First up, let's look at User Context. So here's our User Context class. It inherits from DB Context class, and it's going to require Microsoft EntityFrameworkCore. So in order to add this, go to your Dow class library, right mouse click, Manage NuGet Packages, and type in Microsoft.EntityFrameworkCore. Click on this, go to the latest 3.1, which is 3.1.13 version, and go ahead and install it. So back onto the context class, we're going to inherit from DB context. We're going to need this constructor here, and we're going to have access to each of our tables, our user table, images table, contacts table. And we're going to access them through this object DB set with the type of each of our models. And this is the constructor we're going to use if you want to create it quickly. If you delete this, go to the DB context, type in control period, take the second generate constructor option, go ahead and click on it, and you'll have basically everything here, and this will be the constructor that you'll need. And next up, we're going to add our repository. So let's go over that real quick. So over here, our repository takes the user context class and passes it through this base class. We'll talk about this in a second. It stores the user context class in the repository for later reuse. That way, if we want to query the user, the image, or the contacts, we just type in context.the set name. In this case, contacts, images, or users. And if we want to include child objects, we do the .include, and then we can do any variable here, then that same variable the name. And if we want to include another child, we just add another .include. If these children have another children, then we can type then include and do the same thing, whatever. And that would incorporate not only the child objects, but the child's child object in this query. And we're going to return a type of iQueryable. And what the type iQueryable does is it constructs a database SQL statement, but it does not execute that statement. That way we can pass this object back and do more calculations, more filtering on this object to make it a more efficient query later on based upon maybe some conditions. And then we can call the query to the database. Or we can call the query to the database initially and then do a lot of calculations based upon the data pulled back. We have options in that case if we use the iQueryable. So in our user repository class, when we do getters, we're always going to want to return an iQueryable class. So below our getters, we have a couple post user, post image, post contact, put, and delete. And these call the base class in order to insert, update, and delete these objects. So let's look at that base model class because that's doing most of the work for us. So this base model class is taking a generic DB context class. We have a couple helpers that we built just to update the times. For post, we want a new created time and a new last updated. And for all the put class, we want to make sure that we are updating the last updated to the current time. So for post, we insert whatever type, and it can be generic, but it all has to inherit from our HIDC class. That's how we can pass it into the put helper here. And what we're going to do is we're going to call our dbSet class, which in this case, we're going to pass in whatever class it is. So if it was the dbSet of users, we pass in that dbSet of users, and then the user entity model that we want to update. And then we're going to force a state change. So in this case, for insert, we're going to add, and we're going to flip the state to added. This way, if this model is considered in any other state, it'll be forcefully changed to the added state. And this is important because these models are what's called disconnected, meaning that they go to the client and then the database can't track those models, and then they come back to the database and they're no longer tracked. So if for any reason this entity is in the wrong state, we want to force it into the correct state. And that's really the whole point for this, plus the helper models. That's the point of this base class, because everything else is very similar. Normally the update and add is just dbSet add save change, and you'll basically insert this new class here. So put, very similar. We have to change the state to modify. We use the different put helper. We do an update as opposed to add for dbSet, and then save changes. And delete, very similar, only we do dbSet.remove, and then we change the entity state to deleted, do our save change, and then we return a bool based upon whether or not it's 0. So that's why we have this base class, and that allows us on the user repository class to do an insert context.users and then pass in the model that we're sending over from the client. Same thing with update down here. Update is using the users in this case, passing in a user model. Delete is doing the same thing, the user's context plus the model. Next up, we have our messenger context. Once again, just like the user context, it inherits from db context, and we set each of our tables using the dbSet property, giving it a name, in this case messages, pools, members. And this is hooked into the message repository. Here we have the message repository passing in the message context, which is stored, and we're doing iQueryables for our gets, using the base model class for our inserts, our updates, and our deletes, and including children objects wherever is appropriate. So the identity context is a little bit different. Instead of inheriting from db context, we're going to inherit from identity db context, and we're going to need to include this package right here. So go to NuGet, add this identity.EntityFrameworkCore version 3.1.1.3, and go ahead and install. We won't need any of our dbSet options because those are already packaged into the identity dbSet context, and we'll be able to access those through other classes called Sign-In Manager and User Manager. All right, let's discuss the identity repository that we're going to use to access the identity database that we built. So we're going to use a couple of Microsoft classes here, User Manager to access our user data with the type of identity user, and our Sign-In Manager to access the credentials for signing in, logging out, those sorts of things. And that is also going to use Identity Manager. You may need to add a couple items into the NuGet package manager, ASP.NET Core.Identity, and then this Microsoft Identity Model Tokens, and the System Identity Model Tokens JWT, and maybe even the System Security Claims. So if you don't have any of these, go ahead and add them. If you need to resolve them, go ahead and add them through the NuGet package manager. So we'll store these for later reuse, and we'll run through all these things. So first up is our Jwt Web Tokens. So what this is a JSON web token, and this stores your authentication credentials in an encrypted token. So we're going to create this token, it will store our authentication, and we will store the secret password, which is super duper secret key, in our other web APIs. And if we do that, we'll have the authorization that we can pass between every single API but we only have to create it on this one API, our identity API. So in order to do that, we need to grab the user. So this would be identity user here. And we need to create a claims principal object by using the sign-in manager, create user principal async. And this will create basically a faux logged in user. And then we're going to create our token by using this Jwt security token handler, create token class. And then we're going to pass in the security token descriptor, add our sign-in credentials, like you see here, using the HMAC SHA-256 encryption. We're going to let it expire in a day from now. And we're going to add our subject as the claims principal, casting it to a claims identity type. And then we're going to type in the Jwt security token handler, and we're going to write the token into a string. So this will give us a string that we'll use and we'll pass around between multiple different APIs. So next up, we have registration. So for registration, you pass in a username and a password. And in order to get this to work, we first check if the user exists. If the user exists, you're already registered. So there's no need to register. You just need to test your login. And if you don't find that, then we're going to go ahead and create an identity user, passing in the username. And then we're going to use the user manager to create a new identity user by passing in the identity user that we just created and a password. And this will create it and allow it to be usable. And in other instances, you can create this and then grab a token that there's a class to grab an email token, and you can send that token to somebody's email. They can copy that token, they can paste it in a UI, and then you can send the user, password, and the token over in order to authenticate that not only is that the user, but that user has another way of identifying who they are, in this case, their email address. So that's registration. Login, a little similar. We're going to first check if we have the user. If we don't have the user, we can't log in. Then we're going to check if we can sign in. So if there's anything, if we did do some sort of email token generation and you had not sent that email token over, this will check if you can actually sign in. So if you can sign in, we'll continue. And we'll pass in the identity user, the password, and we're going to do false. This is a cookie, is persistent is for cookies, and lockout failure is you can actually set the number of times where if you mess up the password, you'll lock out the user. And if it succeeds, we're going to pass the identity user object. Otherwise, we're going to pass null. This get user by tokens is going to take a claims principal object, and it's going to return the user. And we're actually going to use this with Jwt tokens so that we can pass the token over to see if you're logged in, and this is how we're going to grab it. We'll show you how we do that in the web API later. We had a way to get a reset token. So basically you pass in the username. We go ahead and check if we have the user. If not, then we don't have a password reset token. Otherwise, we take the user manager class, we generate a password reset token, and this will get a reset token that we can use later to reset the password, which we'll do here. So we have a reset password class where we find the user. If we can't find it, we return false just in case they're putting in the wrong username. And then we're going to call this reset password async, pass in the identity user, the token that was passed in, and the new password. And then we're going to have a logout function where all you have to do is type in signmanager.signout async. And because we're using Jwt tokens, we're going to know what user based upon that token. So you don't have to pass an identity user or whoever it is. You just have to basically use the user that's defined by the token in order to log out. So that's a quick rundown. We'll go through more of these in the web API because that's where we do some extra work here, and we'll show you how all that is hooked together. So now we're ready to create our database. We've created our context, which has an instance to this database, and we've created our model, which defines our schema in the database. So now we need to actually set this up. So in order to create this database, we're going to create this identity builder app. So we're going to do Solution Manager, right mouse click, Add, New Project, Console App, Next, Identity Builder, and go ahead and create that. So that's going to create a default program file here. And the way we're going to work it, we're going to make it configurable for multiple different environments. With this args, we can pass in commands from a command line script, and we can make some settings for the environment or for even database strings. In the case here, if we're going to do production, that way we can kind of hide the database string for the production server and build it from a file that's local to our machine, not checked into any repository. We're going to try to get the data from this app JSON file if we don't get it and we're not in production mode and we're not running this from a script. So if we're not doing that, we're going to run this configuration builder, add JSON, to grab this app settings.json file that we have right here. If you're going to do this, you need to add this NuGet package here. So go ahead and add the configuration.json file. Let's look at the app settings file real quick. We're just going to define some databases here. We have a local and a stage server if we wanted to have a stage for the cloud or another database that we're going to use for testing. So but for our local server, we're going to do server equal dot, which is our local database. And we're going to define the database name as auth, set trusted connection equal true, and multiple active result sets equal to true. So that's how that file is going to be structured. Just go ahead and add it in, right mouse click to the project, do add, new item, and then pick from the .json file here. So we'll add this. So you can add JavaScript JSON configuration file. So go ahead and add that. Name it app settings.json or something else that you want to, but you'll have to match the name up here. And grab this line with the optional reload on change, and then go ahead and build that file. That'll give you a configuration file that you can access, and you can access the values using the path, in this case, identity, context, and environment, which in this case is local, and we define local up here. So we've done identity, local. We can do stage, or we can have multiple other project files here, and we can configure this for multiple different databases. And here we're gonna set up our context by doing the DB context option builder, passing in the identity context that we built up here in Dow. So you may need to add a reference to identity builder, project reference to Dow. So go ahead and do that by right mouse click, add project reference. Do builder.use SQL Server for the SQL Server database. Pass in the database string that we're going to pull from this line right here. And then start up the new context with the builder.options class, and that'll create the context that you need. And then we're going to run this recreate database command, which is going to delete the database and then create the database. And we delete the database by calling context.database.ensure deleted, and we create the database context.database.ensure created. In this way, very quickly, we can just set this as a startup project and run it, and we will get a new database. So deleting the old, if there is one, there won't be one, as you can see. And then it's going to create the new database. And as you see here, we have our authorization database, and we have the tables created from the identity user class. So now we're going to do the same thing we did with Identity Builder on Message Builder and User Builder. So add those console apps the same way we did before. We're going to have an application setting that looks slightly different. We're going to have a database called Messenger, same server, local server, trusted connection, multiple active results. And we're just going to be using the similar structure, only we'll have a different string here, and we'll be using the messenger context. And then we're going to run through the recreate database the same way as we did before. So once again, we're going to run the configuration builder for the app JSON setting, get the configuration file, grab the data out of the configuration file, messenger context.local, And then we're going to grab the database. We're going to run the use SQL Server. We're going to pass the builder.options into the messenger context class, rebuild the database. Same thing here, user context class, use the DB context option builder, builder.options to recreate the database. And we're just going to have a different database. This will be local server database of user. So let's go ahead and create that. So I've just run the user builder and messenger builder here. We're done with this. And we'll check the database real quick. Refresh this. And we have our messenger database with our 3 messenger tables. We have our user database with the 3 user tables. So now our database is created. So next up, we're going to build our web API. And the web API provides route access to your server data. It sets up your authentication. Since we're using JWT, we're going to provide the JWT settings to access each server's endpoint. We're going to configure the response and serialization settings on the web API. We're going to hook all of the database files together. We're also going to configure the database, and we will be starting the database through the web API. So we're going to configure core settings, the cross-origin resource settings, and we're going to define Websocket routes because we're going to be using WebSockets in this application. So let's build a web API. So first thing, go to your solution, right mouse click, add, new project, go to ASP.NET Core Web Application, click next, call it Identity Service. And since I already have one here, we'll click on this just to get to the next step because there's one more thing you have to do. So we're going to pick the API, not the web application. Just click the web API, keep the default configuration, and then click Create. So now that the web API is created, you will need to add some additional items to this class. So by default, you should get everything up here. We're going to need to add Dow Context and Repository. In order to do that, we want to go to Dependencies, Add Project, click on the Dow, click OK, and you'll get the reference to the Dow, and then you can add the context and repository. We're also going to need to add the 3.1 version of this authentication JWT bearer. We're also going to need to add the 3.1 version of identity model.tokens and ASP.NET Core Identity and EntityFrameworkCore. So go ahead and add those in. I think at the time 3.1.1.3 is a valid version. So go ahead and add those into your project. So the next couple lines, add scoped is going to add an external class into the dependency injection system. So if we wanted to use identity repository, which we use throughout our controller, we're going to want to have this available. So we're going to have to add this or any other class that we want to have available in the constructor for dependency injection. We can use the add scope mechanism. We want to use the add DB context for our context class. This will give us an option to pass the DB string into our constructor. So this will go into the identity context class here as this DB context options. And add default identity will add your identity user and make it injectable. It'll configure all of these settings, so we're not going to require an email confirmation. We're going to have a setting of 8 characters. We're going to require at least 1 digit, 1 lowercase, and 1 uppercase. And then we're going to need to add Entity Framework Store to get this to work with Entity Framework, and we're going to pass in a type of identity context. And by adding these, you're going to make them available for dependency injection, and you're also going to do some configuration with this add DB context with the use SQL Server and add default identity. This is how you need to set up the identity user and hook it to Entity Framework. So let's discuss the startup class because it hooks all of our stuff together, our database, our routes, it configures our security. So let's just look through it real quick. and we'll go for it line through line. So on our configuration services, we have two ways of grabbing the database connection string. So we're going to do this either through environment variables, that'll be our preferred, or we're going to grab the configuration data from the app settings.json file here. And then we can grab that data. That'll be a backup. Normally, especially for production, you don't want to expose any of that data because you could check it in and somebody could grab it and people could see your password, your username and passwords, and that can allow them to gain access. So you want to protect that as much as possible. In this way, you get environment variables. You have it either on the local system, or if we're putting this to, let's say, a cloud system, we can define those variables locally, and that way they can be hidden and protected just basically for anybody who has access to the cloud service or your local environment. So it kind of protects it by the machine that it's on. So in order to get to these environment variables, if you don't know, just go to My PC, at least this, if you're on Windows, go to Advanced System Settings, Environment Variables, and in these system variables, you can go ahead and set your connection settings. So in this way, we've identified this as identity context. If we can't find this, we'll actually go to the configuration and grab it. And right now I don't have it set, so it's going to grab it from the configuration data. In order to determine where you're going to grab it from, we have an environment setting. So we could set here local and let's say a stage, just for example. And then we can define all of our settings, put a password here if we want to. So some of the stuff that isn't critical, isn't production, then you could maybe expose these in configuration files if you wanted to, and then configure multiple different environments. Let's say you had 10 or 15 different environments. This would be a pretty good way of looping through all of those, except for the production. You wouldn't want to have it in that file. So we need to inject our repository into the dependency injection system. So anytime you're going to inject an external class, you're going to want to use the add scope. So we're going to add the identity repository. The add DB context will also inject your context into the dependency injection system. And we're going to pass in a set of options, use SQL Server with the database string that we retrieved above. So next up is our token. So we're going to do service, add authentication, and then we're going to set this to the bearer type authentication scheme. So this will define the way that our client has to send our JWT token over to us. In this case, bearer space, and then the token. So that's how we'll set it up on the client using the authorization header and the bearer space token as a pass-in. And then we're going to add JWT bearer, set a bunch of options. So we have on token validation parameters, we're going to add all of our parameters. We're going to define an issuer. We'll define that externally in the JWT token creation, validate audience. Same thing, we'll add that in the JWT token creation class. We're going to define that in the when we create the JWT token with these values. We're going to set a lifetime, so we'll define the lifetime of the token on whenever we create the JWT token. We're going to make sure that the signing key is validated, and then we're going to set a symmetric security key with super duper secret key as our name, and that way we'll need to define this when we create our JWT token to have this key so that everything works. And then just we're going to hook into some events here just in case something fails or something is validated. We can do some logging or just put a breakpoint here for, let's say, when it fails, and just to kind of get a reason as to why it failed. So finally, in your configure class, make sure that we add app use cores. Define our origin. We're going to do localhost 4200 for our Angular app. Allow any method and allow any header. We can restrict these a little further because I'm not using all the headers, but for now, this works for our system. HTTPS redirect will already be there, as will be routing and authorization. Make sure you use authentication into this mechanism in order to add the authentication mechanism. And then the endpoints will be here for your controllers. So by default, when you build a new web API, you're going to get this controller class. So we're going to need to clean this up just to show you how we'll start out everything. Go ahead and delete everything here. We don't need the logger class. And we also don't need this weather forecast class. So this will get you all set up, ready to go to modify this controller for all the other controllers that you're going to need later on. So let's go over the rest of the service here. So the program file, program.cs, basically configures your system. We can actually do a lot of the configuration that we did in the startup here by adjusting some of these settings here. But we're just going to run everything through setup. It makes it a lot easier, a lot cleaner. We have our app settings, which we've discussed before. Here we can have a set of configuration data that we can add, that we can change by project type or environment in our case. And we can grab all the data we need at runtime based upon a certain set of settings. We have our identity controller, and all these controllers are added by default. We'll go over this in a second in more detail. And we also have our launch settings, which define our settings for IIS, our profile data, and our identity service data if we're just going to use the web start. So in our case, we have gone to the web start process, or you can go to IIS Express, but we're going to use this identity service here. We're going to turn off the browser that gets launched every time. We're going to rename the launch URL to give it a different name. We're going to trim down the application URL. And here, if you want to, you can set many different environment variables for your local system. So we could do that as opposed to going to the environment variables on our particular system. We could set those configurations here. And if we're on a team, this would probably be the best place to have it. But just notice you don't want to check in any data here that you don't want anybody to potentially steal, because it'll be available to a large number of people, or could be available to a large number of people. So with that, we've gone over all the different files, settings, and data within the Identity Service Web API. Let's go look at the other APIs. All right, let's go over the User Service Web API. Very similar to the Identity Service, just a couple different changes. One of the biggest things, we're going to have to add this newtonsoft.json package. So go ahead and add the latest package here. Go to your user service, basically go here and do manage NuGet packages, and go ahead and add that in. We don't need all of the identity stuff here, but we need the EntityFrameworkCore, the access to Dow, and the token data here so that we can get authentication. So scrolling through, we're using our environment variables similarly to how we did before. We have our configuration set up with app settings, so we're grabbing this file and we're going to run through and grab some of this data. We're using a different database, but everything else on this local file is the same except for the user database. So we're still adding scope for user repository. DB context, very similar. We just have a different DB string, different context. Our add authentication is just a copy-paste operation. You're going to need that because we're going to have all these settings created on the identity service, and they have to be matched here in order for this to validate. So make sure that everything is just a copy-paste operation from your identity service settings. And down here we have services.add controller. I took this out of identity service. By default, all of your controllers that inherit by controller base are going to be automatically added to the project at runtime. So this technically isn't necessary. But if we want to change the serialization settings, we're going to need this, and we're going to need it to hook in the add newtonsoft JSON. And what we're going to add is this reference loop handling, and we're going to ignore. So if there is a class that causes an infinite loop, we're going to ignore it. And we need it in this case because if we go to our user class, we have a list of contacts. And in order for Entity Framework to recognize this, we need to add this user ID access, and we need to add this user class here. And the current implementation of the JSON serialization for .NET does not handle this. So we had to downgrade to the newtonsoft JSON, which is the way that we typically did it in the past. Add this ignore data member attribute to this user class, and it'll ignore creating this class. So we'll basically solve the infinite loop problem that we would have had. Of course, it'll error out once it recognizes that there's an infinite loop. So everything else is the same. Our core is the same. We're going to localhost 4200. We're adding authentication. Well, this is at we're adding authentication. Authorization is added by default. But everything else is the same. We just have different app settings. The launch settings are slightly different. We have a 502 route as opposed to a 5002 route as opposed to a 5000 route. Once again, we turned off the browser. We gave it a different launch URL name. And yeah, so that is the basic overview, the differences on the user service. And now we'll show you the differences on the messenger service. So let's go over the messenger service. So once again, everything is very similar to user service, only we're going to have this WebSocket class in Dow. So when we add our Dow here, we'll have access to this WebSocket class as well as the repository and the context. We're also going to have to add a few more NuGet packages for the WebSockets. We'll show you that in a second. But same thing here, we have environment variables that we're grabbing, or we're going to the configuration. Our configuration setting is slightly different. We use a different name. We still use the environment variables, and we have a different database, in this case, Messenger. So back over here, we're adding our scoped repository. We're adding our DB context. Copy paste the Jwt Web Token data. We're adding controllers with the Newtonsoft because we have two children objects on the pool class, which has members and messages. So we want to ignore those infinite loops. But then we're going to add services.addSignalR. And because of our infinite loop issue, we're also going to need the add Newtonsoft JSON protocol, because once again, the default out of the box serialization for Microsoft doesn't handle this at this moment. It'll handle it in the future. So we're going to want to set the same reference loop handling to ignore. In order to do that, in order to access both of these, we're going to need to add these two packages, ASP.NET Core SignalR, and then add the one that has protocols, Newtonsoft.json. And just a few more changes down here. On the cores, very similar, but we're going to need to add this add credentials to get the WebSockets to work. We also need to do the use WebSockets, and we're going to need a keep alive interval. I put 20 seconds. You can do up to 120 seconds or 2 minutes. That'll work too. But I have this going every 20 seconds. And we also need to add this map hub message sockets and this route right here. And we'll hook into this route on the front end by defining the backend API plus sockets.messages, which in this case is using 5001. And once again, we turned off the browser. We added a different name. And also on all this, I don't know if I mentioned it on the user service, make sure that you set this from IIS to messenger service. We're going to need that whenever we start up the project. We're going to launch all, and there's some additional configuration you need to do for IIS that we're not going to go in through here. But everything else is generally the same. Just copy paste and change some of the repo context, make sure your JWT classes, and then some additional configuration for the WebSockets class that you need to do. So now let's look at our Web API controller. And this is how we're going to access the server. And before we start, we're going to need to add a couple references. So we're going to need to add Dow reference for the user repository, DTO and Vue model. And we're going to need to add authorization for the authorization tag and HTTP for our return status code. And then we'll be ready to go. So at the top, make sure you add this authorization tag to your controller. You should have these controllers set up this way automatically out of the box. And the name will be identity controller. And we're going to pass in the repository through dependency injection into the controller. The first method up is our get check-in login. And what this is going to do is this is going to pass the JWT token. If the token is valid, it'll continue to pass through. And it'll get this claims principal user loaded into the controller automatically. And you will use that to grab the login data from this class. And let's look at this real quick. So this just gets user async from the claims principal object. and then it returns the identity user. So once you have the identity user, if it's null, then you don't have a valid user, we'll return null. If not, we'll grab the token from that logged in by passing in the login username. And this will go through, grab the identity user, then grab the claims principal, and then start building the token. We talked about this in a previous video, but we're going to build the signing credentials, the expiration date, set the subject to the identity, cast it to claims identity, and we're going to define our audience and issuer. After that, we're going to return in the login view model to the front end, giving you the token as a string and the user login identity to store on the front end. Next up, we have registration, and we're going to pass from the front end the login DTO class. And this will have username, password, as you can see here. So with that, we can post a registration. Once we've registered, we can post the login class, get the login user, build the token like we did above, and then pass that back to the login view model, just like we did above. Next one is login. We're going to do the same thing, login DTO, but instead of registering, we're just going to grab the login, build the token, return the login view model from this process. The next one is get password reset token. We'll pass in a username, return the token, and pass back a DTO with the code. And we'll need to do that just to get serialization to work correctly. It won't directly take a string. This password reset DTO can bring back the login DTO information, but also has a code. So we're going to use this to receive the new password reset token, and then we'll pass it in right down here to reset the password. So here we have a post password reset DTO model. And then we're going to make sure that we can actually do the password reset. If that's true, we're going to build the login, build our token, and then return a login view model to continue the login process. And then if not, we're going to turn a status. We're going to return a null. And the next thing we're going to do is post a logout. Like I said in a previous video, when you log out with the JWT token, you'll be able to identify the user and it'll know who to log out. So it's simple to just pass the login method here, and we'll do the sign out async, and we're good to go. And then we're going to return true if there's any issue, or return false. So a couple things to note up here. If you're posting any data, you need from body in order to get this to serialize correctly. So make sure you have from body. We also have allow anonymous on all these methods because these methods are before you log in. And the check login method really needs the token, and that's really how we check to see if you have a valid token, that it passes through here so you can continue the process. So make sure you have the allow login or allow anonymous on all the methods except for that check login method that's going to validate the token and return back the login view model if it's done correctly. All right, next up is the user controller class. We're going to need to include some external files. Dow repository, user model, HTTP, and authorization will be required to get everything to work, and also system.linQ. So first up, let's add the authorization tag. We should have the API controller and the route, and we need to inject the user repository class. So first up, we're going to get all users. So we're just going to call get users and we're going to filter all the ones that aren't deleted and aren't disabled. When we do the toList, we're actually going to make the call to the database. Remember, this is an iQueryable class that just builds up the query to the database, and then the toList are the first and default that we'll show in a second. Those are actually going to make the call to the database. And the route here is going to be the controller name, basically user minus the controller. So it'll be user/API/v1/users. And that's how we'll access it on the front end. The next one up is get users, API v1 users, passing in the authorization ID. So that authorization ID will be mapped to this string, authorization ID. It'll be passed into the get users, and we'll call the first or default that matches that authorization ID. Next up, we're going to post users. So API v1 users, same tag or same route, but we're going to do post users. We need to add this from body for serialization. We're going to pass in the user model and just go ahead and save it with post user. Next up is put user. So we'll have the HTTP put API v1 users, and then we're going to need the from body for serialization for the user, and we're just going to go ahead and put the user. And make sure you, as we said before, you have this authorization tag, otherwise this won't force authorization. And all of these are going to be allowed only if the JWT model that you created on the identity service is valid. So make sure you're passing that in to the bearer to the authorization header as a bearer token. So last up, we have the messenger controller, and we're going to need to include some external classes. Dow.repository, Dow WebSocket, so include your Dow class, include your models class while you're doing that also. We need to add the ASP.NET Core authorization, HTTP. Should already have the MVC, but you'll need to add the signal R, the link U, and the threading.task. We'll have the authorization tag up top, should already have API controller and route. In the constructor, we're going to inject the messenger repository and an iHub context with a message socket type. And we're going to add these hubs to private fields up here. First up, we have our get pools, and we're going to call get pools, which will be messenger /API /v1 /pools /members /auth ID. And we could do pools /auth ID, but this just conforms to REST standards since we're going to be grabbing the authorization off the members class. So this auth ID will be mapped to this string of auth ID. The names will match there. And we're going to grab all pools. We're going to filter where members, any of them, equal this authorization ID. And then we're going to toList to make the database call. Next up, we have a post to pools. So this will be messenger API v1 pools. And we're going to need to pass the from body of pool with the model, and this will post the model to the pool, and then we'll take that return result and we're going to send it through the WebSocket calling hub.clients.all.sendAsync, and then we're going to call send pool, which will map to the client front end, and then we're going to pass in the pool object that we just created. Next up, we have the post message. So we're going to do messenger.api or /API /v1 /pool /messages, and then we're going to pass in a message model using the from body for serialization, and then we're going to post the message, get the message result, post this in the WebSocket, and it'll be sent over to the client with hub.client.all.sendAsync. And next up, we have post members. Very similar, messenger API v1 pools members, and we're going to do the from body of members, post member, return the result, hub client all send async, send members of members. And the last one, we're going to put members. So we're going to do messenger API v1 pools members, from body for serialization, members model, put the member, and then we're going to send the member through the WebSocket using update member, passing in that member. So that concludes the messenger API. Let's discuss the overall structure of the Angular app. One of the big items is going to be your model, and this is going to store data from your server. It's also, we can add functions related to those models or the child elements in the model to do calculations or some checking on the values within the model. Say if we wanted to sum up data based upon a condition, we could put a function in the parent object to check some values, count some values in the child model. We're going to have APIs, and these APIs are going to be separated for each microservice, and they're going to define the routes to our endpoints. And we're going to try to keep these separate and simple. Our model services are going to combine our models and our APIs, and they're going to be there to call the APIs to get the data that we need. And we're going to be able to store that data throughout the length of the session of the app. We're going to build views, and those views are going to describe the DOM. We're going to hook in with Bootstrap, and that's going to help us style the DOM. We're going to have a component class that helps you manipulate the DOM through JavaScript. And it's going to access the model service to call the get, post, put for your data. We're also going to have helpers and utility classes. And these are going to add extensions onto your capabilities within the app. It can also link 2 or more code bases together. And if we reuse code throughout the system, we'll have one location to make a code change that we can use throughout the system, just injecting that wherever we need it. So let's talk about your models. So first up, we're going to construct this HIDC model, which is your base class model that is inherited by all other models in the database. And starting out, just go to your app folder, right mouse click, new folder, and go ahead and create a models folder. In there, we're going to segment another folder called base, and we're going to add a new file, hidc.ts. So this is what the file looks like, and it's mapped to the values here. They're mapped in camel case as the .NET Core code comes over in camel case. So capital I, lowercase d will be lowercase I, lowercase d, and so forth. So we're going to map an int to a number, an is deleted, or the boolean to a boolean, is deleted and is disabled. The date time offset to a date, and the row version as a byte array to a string. And in our constructor, we're going to build a constant value with a set of values that are preset. If any of the values in object are undefined, they will automatically get these initialized values. After that, we're going to set the value created here to the values that are stored here in the class. So we'll go through the setter methods down here. Similarly, down here we have an update function that we'll use whenever we're updating the values. And we'll come through and we'll set the ID, created, last update, and row version. We won't set the is disabled and is deleted because those will be updated from the front end, and there may be a timing issue or a race condition where you set one of these values, where you changed one of these values real quick, and just because of a delay on the server, it came back and it reverted these changes. But your created, last update, and row version, those are all going to be handled on the server, and the ID gets set initially. So we're going to want to set that, let's say if you do your first save and then you come through and you update, you'll get your initialization value. So these will come from the back end. This will be updated on the front end once the back end updates that value from the initial set. At that point, you're not going to change it. So, and it won't be set on the front end or configured or controlled in any way, shape, or form. All right, so let's go over the user model. And the user model, create a folder called users just to segment it out. Add a Typescript file called user. And we're going to call export class user, and we're going to extend our HIDC class. And we have the mapping of the models, a string to a string, string to a string, date to a date, image to an image, a list of contacts to an array of contacts. Our constructor, we pass in our object, cast it to that object. We call the base HIDC, calling this super method. That calls the base, whatever you have in the extended class, this is what will be called. And we're going to pass in the user, which is of type HIDC also. So it'll have all the values in HIDC. We do the initialization. Basically, when you pass in this object, if there's any undefined values, these will be the preset values that are assigned by default. So then we're going to go through and do our assignments. We're going to check if we have a birth date. If we do, then we're going to new up a birth date and assign it to birth date. We're going to check for avatar. If we have an avatar, then we're going to new up an image and assign it to that avatar. We're going to check if we have a contact, and then if we do, we're going to loop through the contact list, pushing a new contact on each one. Update, very similar, except for you're going to call the base class .update. We're going to do the same thing with the initialization. We do not need to set anything here. We're going to set the ID and all the row version for the concurrency and the new dates in the base class, but we don't need to assign the auth ID. We've already assigned that. We don't want to assign the name, profile, and birth date, just in case during the process of save you make some changes and then it reverts those changes. So we're going to go through the avatar, check if the avatar is there. It is not there, and then we're going to create a new image, and then we'll go ahead and update the avatar. And this is just a guard check. This shouldn't happen, but just in case. And in the context, we're going to loop through the context, grabbing the object plus the index. We're going to try to find initially the object by the ID. And if we do find it, then we're going to call the update of the contact class. If not, we're going to just verify that we haven't hit the end of the array. This shouldn't happen, but all these should be in order. And so we're going to loop through the index if we can't find an ID, and we're going to just assign the item. We're going to check for the item at that index and update that item with this value. So here we have our image model, very similar to how we're doing things before. We're going to map the file to a string. We have our constructor. We're going to pass in a JSON object of type image. We're going to cast it as an image. We're going to pass this to the base constructor to assign all the default classes. And we're going to initialize the file to an empty string. And then we're going to grab the data from the object. If it's nothing, then it'll be an empty string. If not, it'll take the value that you passed in. And then we're going to assign that value. On update, we're just updating the base model classes, as anything you do in the file will be initialized on the client and passed over, and you don't want to have any race conditions revert any changes you made. Next up, we have our contact class. Similar to everything else, we're going to map a number to an int, string to a string, and everything's in camel case. We're going to pass the JSON object in, cast it to a contact object, update the base class, do default assignments for the object, and then overwrite those assignments if there's anything in this object. And then we're going to do the assignments from that object to the classes models. Update, same deal, cast the JSON object to a contact, update the base class, default some values if any of them are undefined, and then of course in this case we're only going to assign the user ID because let's say you do a group update for users that also has contacts, you won't have a user ID initially. The contact ID won't have a reference to the contact ID because, or the contact class won't have a reference to the user ID value because it hasn't been created yet. So you're going to want to make sure that when the server sends you over the updated value, you make the assignment of user ID based upon the new ID sent from the server. All right, we're going to map the pull model to the pull model on the back end. We're going to map this list of members and list of messages to an array of members and an array of messages. So the constructor will take a JSON object, cast it to a pull type, update the base class. It's going to default members and messages to an empty array. If members exist, loop through each member, push a new member onto the members array. And messages is the same thing. Loop through all the messages that come through the object, add it to the messages array up here, pushing a new object onto the messages array. Update is the same as our other updates. We're taking a JSON object, casting it as a pull type. We're updating the base class. We're going to default the members and messages to a new empty array. We're going to check if we have a message. Then we're going to loop through the message with the object and the index. And then we're going to look through the messages that currently exist, try to find a matching ID. If we find it, update it. If not, we're going to take the object as an index and we're going to update that object in that index. Same thing for members, looping through with the object and the index, grabbing the member. If we can find it, we're going to update it. If not, we're going to use the index to update that index value. So here's our message object. We're going to map the int to a number, string to a string, string to a string. The JSON object passed in will update the base class. We're going to default assign pool ID of 0, empty strings for text and from auth. And then we're going to do the assignments of this pool ID to this pool ID, this text ID to this text ID, and this from ID or from auth to this from auth. Update, very similar, passing in the object, updating the base class, assigning the pool ID to 0, text to nothing, and we can do the from auth here also. And we're going to assign the pool ID, and just like the users class that we discussed before, we may not have this pool ID value assigned because the pool may be new, and we're going to send messages over when we create the pool. So on the server, it's going to define the pool ID, and then we're going to need to assign it on all its children classes to make sure that it is in sync. All right, so our member object, we're going to map the int to a number, string to a string. The object passed in is going to be cast to a member object. It's going to be updated on the base class, default value of 0 in an empty string, and then assign the value from this object to the values in the model. On the update, very similar to how we did messages, we're going to cast the object to member, update the base class, do the default assignments, and then assign the pool ID, which may not be set. It may be set to 0. We're going to assign that based upon the ID given to us from the server. All right, finally, let's map our identity user to our identity user in .NET Core. There will be some differences here as we're not going to map all of these properties. So the only ones we really care about are ID and email, at least at this time. There's more that you can add, so add the ones that you feel is appropriate, but right now we're just using the username, which will be an email, and the ID, which will be a string. So in the identity user, we're going to cast the identity user to an object. We're going to set these default values. We're going to assign them to the properties here. And on update, we're just going to assign the ID because the initial ID will not be known until the server saved it, assigned the ID, and then passed it back. All right, let's discuss a few more of our models. We have DTOs and Vue Models. And the differences between the two is that a DTO, or a data transfer object, just has data that transfers back and forth from the client to the server and from the server to the client. But it doesn't pass back any model data from the database, and it's not used to assign any model data to the database. So that's why we identify these as a DTO, and a Vue model will have data from the database. So you need to decide what to do with that, what to store it on the front end for future use or for future updating. So that's the distinction between the two. But going through the login DTO, we're going to map toString username and password together, initialize it with the object with an empty string, and then do the assignment onto the property. Password reset inherits from login DTO, and it just adds a simple string of code, but it needs to call the superclass in order to initialize the login DTO data. The login Vue model will take an identity user. So we're going to take the object, assign a null and an empty string, and then new up a user and assign the token, and we're going to map it over here, identity user and a string token. So now you're going to know you're going to need to do something with this identity user on the front end because it's a value that you want to store. So let's talk about these helper functions right here. So these are basically services that we're going to inject everywhere throughout our system. So they'll all have this injectable tag provided in root. And they'll provide us access to more complex functionality without having to write it again and again and again. That way, if we make changes for any reason centrally, it'll be provided throughout the system in a common way. So the first one up is DOM helper. The DOM helper gives us access to common elements related to the DOM that we need throughout the system. And we're going to inject this with this injectable tag provided in root. This provides lazy loading. It also means that we don't have to add this service into the providers array. So that's another benefit. And this would load it all in at runtime, regardless of whether or not it's being used. This is just going to add it whenever it's being used, which is at the very beginning, so it'll be loaded quickly. So the DOM helper, just starting out, has a couple properties. It's basically trying to get the route or the location where it's at so that it can determine which environment it is, whether it's local, production, or local or mobile local. So to get local, in our case, we're just going to look for a local host. So this assumes there's no competing values of localhost, and if it has it, it's going to return greater than 0. So for production, if it doesn't have localhost, and once again, this assumes we don't put localhost somewhere in the URL name, it should equal to -1. It's kind of a simple way we use to determine the differences there. Is mobile local is a little different because mobiles use a file system. So we're going to look and see if it's at the document object, which we get on the constructor. It's an injected element that we import from Angular Common. So that's how we access the document. The document URL index of HTTP or PS is equal to -1. Basically, it doesn't find one or the other. And based on that, we're going to return a set of locations that the client is at. So for the localhost, it's 4200, and we just gave some dummy values here for mobile and production. So the host name, we're just going to basically give this a shorthand. And since this can be used throughout, we want to do this. Otherwise, this is a little much for Gitter. But we're just going to look at document, location, host name to get the host name. Local storage, we're just going to pull that back local storage. This isn't even really necessary, but it's there, so we're talking about it. So here we have is small, and this is going to look at the window object, and it's going to look at the inner width, and we're just basically mapping this up with what is in Bootstrap, which is the style sheet that we're using, and these are the settings for Bootstrap. So we'd want to modify these so that we know when different settings change, we can do some property changes, and we can grab these values very quickly. So next up, we have the model helper. This is an injectable service. This will be lazy loaded in root. We are going to take the DOM helper class from before, and we're going to inject it in the constructor. And we're doing this to detect if we're in the local environment, and if we are, we want to log the values that are different. So what this class basically does is it grabs the object's keys value so that we can check the length if this is an object, the string name if it's an object, and it's going to go through and do a check for every object, or it'll not be an object, it'll be a property, and it's going to do a comparison between those two property values. So if it's an object, it'll do this check. If it's a property, it'll do this check. Therefore, it'll loop through, and we'll do a deep equal if it's an object, and if property, will basically just take the true-false value. So we're going to go through here and loop this whole thing, return a true or false value. And if it's false, then these values are different, and you're going to go ahead and log those and send back a false. Otherwise, it's true. We'll skip the logging and return. And then in production or mobile, you won't be logging anything. The navigation helper is another injectable service that'll be lazy loaded. It's going to inject the router class from Angular router, and we're going to use these methods throughout. Basically, we're going to check 3 separate routes: is home, which is our base route, is messages, which is our messages route, and is user, which is our users route. And then we're going to navigate using the router.navigate by URL to go to the different routes that we want throughout our system. This will be hooked up in the app routing modules, where we'll define the path, which is the base class, messages, or users, and we'll hook up the components that we need to hook up to define what is the starting point for this route. And these two working together will help us route through the system. Next up is our API service. And the API service will take a number of imports as shown right here, and we'll see them in use down below. We're going to need an environment property just to store what environment we're in, a bearer property, and this is going to store the token that we're going to use for authorization, a set of base headers that we're going to include in every call. Our constructor will inject the navigation service, our DOM helper, and the HTTP client provided by Angular. So we're going to check the environment by just doing the DOM helper is local, is mobile, or else it's going to be production, and then it'll just tell us which environment this is in. We can build the headers, so we can take the base header class in the get shown above, and we can append the authorization bearer and bearer string. Make sure you have a space here, and we can append that to the headers and return the headers. And in our get method, we're going to use the HTTP client get method. We will pass in a path for the endpoint for our API. We're going to build our headers. We're going to only try this one time, so retry of 0, and we're going to catch errors by passing in an error. So right down here we have our HTTP error response. We're going to build a message based upon the error, or we're going to build an error code and an error message here if it's not an instance of error event. If the status happens to be 401, we're going to be unauthorized, so we're going to go back home, and then we're going to throw the error. And up here we have the put statement. We'll define a path to the API to place that object. We're going to pass in the model object to the body. We're going to build the helpers and then do the retry and catch error. Post, very similar, except we're going to use .post, pass in a path, pass in the model, build the headers, and then run the method. And for delete, we are going to pass in the path with the ID of the value you want to delete, and we'll pull the object from the back end and then go ahead and delete it. And this right here, we're going to build the headers and then only do no retries and catch our errors. So let's look at our authorization service. This is going to be injectable into any class. We're going to lazy load this. So the base string is going to be the only property we need to store and figure out. And we're going to do that by going to our API service, which is going to provide all of our base routing functionality. Check the DOM helper, check if it is local. We could also do production or mobile. And we're going to set the base string to HTTPS, localhost, and port 5000, since that's what we were using for the identity controller. So with this base function, we can pass in the rest of the route in order to get the final route for this call. So for the first one, we have identity, which matches the controller name of identity. API v1 check login. So that's going to map to this because it has the proper verb tense and the proper verb tense here. So these will match, and we're going to do a call. Basically, this one is going to take the token. We should have a token stored on the front end. If we don't, this will fail. But if it succeeds, we'll get all the login information that we can pass back up in the callback to the class that calls this in order to set the login view data if this succeeds. So next up, we have post registration. So similar, we're going to do a post, and we have a post here. We won't have to have a token on this one, but we don't do any of the token setting here. This is just an abstract class. So we're going to do the base of port 5000, identity API v1 registration, which you can see matches the route here. We're going to pass in a login DTO, and as you see here, we're receiving using a from body the login DTO, which must match and complete serialization for this to work. Otherwise, you'll get an error, and you need to fix the mismatch model in order to get it to work. Next one, post login. Same thing, we're going to do post. Post, we got our route API v1 login, API v1 login, and it's on the identity controller. And this one, same thing, login view model that will pass back up. Get reset token. So this is very simple. We have the same base class identity API v1 password reset token, which you see here. And then we're going to add in the username here. So we need to make sure we do a slash and then add the string username. And this will give you a reset token that'll be passed back, and we'll push it up through the callback to the class that called it. And it'll do all the setting for the password reset DTO here. Next one is password reset. So we're going to pass in the password reset DTO. We have the code. We're going to hook up the username and password, and we're going to send it back to do the reset. But the call will be a post, which you see right here is a post, API v1 password reset with the identity controller pushed up front, password reset DTO passed in, and then the from body password reset DTO to receive. Finally, we have the logout. So when we call post logout, we are going to actually pass in the token. So this is why this is not anonymous. That way it'll know which user it is. And basically this call right here will call the base class, which will take the user, and then it'll use the user through the sign-in manager to log out. And as you see, we have identity API v1 logout, and these are both post statements. Next up, our pool service. Same thing in the constructor. We're going to figure out where it is, and we're going to set the base route, which in this case is going to be 5001. We will have a get pools with members, so we're going to do API base plus messenger, since this is the messenger controller. API v1 pools member right here, plus auth ID that we'll pass in. Make sure you put that slash before that. We'll subscribe, and we will get a list of pools back from this call. Next one up, we're going to post pools. So we'll pass in a model of pools, post with our base route, messenger for our controller, API v1 pools, which you see here. We have a post. We'll need tokens for all these, by the way. There's no allow anonymous on these endpoints here. So you're going to pass in the model, and so you're going to have a from body on this side with the pool and a model, and the data types are going to have to match like we showed earlier. Post messages is next. Same deal. We have post, API v1 pools messages, API v1 pools messages, and this is kind of the structure of the model in the other model. So pools.messages would be kind of the route that you'd use in order to match up the structure of the route. That's kind of a REST standard that you need to do. And since this is going to be getting all its data from the Websocket, we're not going to subscribe to anything here, because we're going to let the data be figured out based with the Websocket tool. Next up, we have post members. So we're going to pass in a member, base class messenger for the controller, API v1 pools members, passing in a member type that has to match, and using the from body to get the serialization to work. Next one up, put members. Same thing, base class identity or messenger controller, API v1 pools members, as you see here, with the put verb and the put verb here, passing in a member object with the from body to get the serialization to work. Next up, we have the user service, and the user service is going to resolve to the base path here, and for our local, it's going to be port 5002. We have a get all users command. Get to API or users API v1 users. So this is the user controller, API v1 users, and we'll get all users here that aren't deleted or disabled. So next up, we're going to get a user by auth ID. So get your user, we'll pass in an auth ID. We'll call the base class plus the controller API v1 users, and appending the slash and then the auth ID. So we'll have that here, and the auth ID will match up with this string. We don't need, if we're passing it through the parameters, we don't need a from body. So next up, post users. So we can do this .base controller API v1 users, passing in the users to a post verb, matching the post verb and the route here. Once again, from body user model that must match for serialization to work. And the last one up is put. So very similar, put verb. Here's our route, from body for serialization, and a user model that must match the user model that you pass in. And then we're going to send the return results up to the parent class that calls this, and they'll resolve what to do with the model data. So let's talk about our WebSocket. So in order to get WebSockets to work on Angular, go ahead and run this npm install Angular or asp.net/signalr and go ahead and save it for in your packages folder. And the way it works, it is an injectable service, once again lazy loaded. It has 4 outputs to allow somebody to listen for these model changes and act on those model changes. We start the WebSocket with this hub connection builder, and this is just login configuration. You can change these levels or omit this as you like. We're going to define the URL, which is the messages URL, which is on port 5001. And we define the route to be sockets messages, and we did that in the startup folder. So on construction, we're going to start this up, and we're going to type in messenger or message.start to start this connection. And the messenger, we're going to listen for these various messages, and then we're going to take the type. So send pool would be the send async, send pool with the pool type. Send messages would be right here with send async, send message with the message type. So we'd send the message here, pass it in here, omit it here. Same thing here for the members, send member. That is wrong, so that should be add member. So add member is going to be hooked up over here to add member. We're going to pass in the members, and we're going to output the add members to add hit. We're going to be listening to the update member here. We're going to pass in a member. We're going to hit the output event here, update hit, and we're going to emit that. And we'll be listening for these events in another class, and we'll be acting on the model changes there. So here in our datas folder, we're going to build a couple of classes that are going to bring your API and your model together to grab the data from the server, pull it over to the client, and store it for later use. So our auth data class is going to bring together our authorization service, which is hooked into our identity service on the back end, our identity user, and it's also going to grab our token if we have one stored in the browser. So this class is injectable, so we can basically use it wherever we want, and we're going to lazy load it. So the first call up is check login. We're going to pass in a callback so that the other class that calls this can know when this has actually happened. And we're going to check if we have a stored token. If we do, we're going to set that to the bearer, and we're going to call the login from the service. This is going to return a login view model, which we're going to pass the JSON object into, get the view model, pull the user and the token off of the view model. We're going to store the token. So this will be the current token that has a day timeout. And we're going to tell the class that calls this that this succeeded. If it doesn't, then we're going to tell the class that calls this that it didn't succeed. Next one up is login. So this is going to require the class to call the login DTO, so you have to build it and set the username and password. And we're going to post the login. We're going to get a login view model back. We're going to set this to view model. We're going to grab the user and the token from the bearer, set the token just like we did up here, tell the client that it succeeded or it failed. Registration, similar thing, passing in the login DTO, and then we're going to get the login view model back, set the user token, store it, tell the client if it succeeded or not. And then log out, we're going to post the login, we'll tell if it succeeded or not, and then we'll tell the client. Get password reset, we'll pass in the username, call the password reset service, get the password reset DTO. We're just going to save it to this value here for whenever we decide to post it later. So then we're going to post the post password reset's going to pass in the password reset DTO, and we're going to call the service. And if it succeeds, we're going to build the login view model, store the data, tell the client whether it succeeded or it failed. So that's all that this does, and this gives us a way to get the data that we need and tell the class that calls this whether or not the value succeeded or not. So the pool data class will bring together our pool service or our messenger service on the back end our message sockets or sockets from the back end. We'll also pull in the auth data to get the authorization ID for the pools that you belong to. We're going to add multiple output events to tell whoever's listening to this that we've actually updated these values. And initializing these values, we're going to go to the socket, we're going to do send hit, and we're going to subscribe to that socket. Let's look at that real quick. So whenever we get these messages, remember we're going to do these emit. So we will grab this up here on the pool data, and we're going to subscribe to them, and we're going to call a couple functions that will basically check if you have these values or not, and either update it or add it. So let's go down here. We have resolve message. We'll just check and see if the message exists in the pool, or there's a pool ID, sorry, and then we'll add the message to that pool. Resolve member, same thing. We're going to look and see if we have the pool. If we do, we're going to find the member. If we can get the member's index, then we're going to update it. Otherwise, we are going to push a new member. Resolve pool, we're going to check if we have the pool or not, and we're going to either add it or we're going to update the pool. So to get the pool, we're going to call get pool, pass in authorization ID, and we are going to bring back the pool and just loop through the list of pools and then assign it to your pool object to be used later. Post pool, we're just going to call the post and we're going to receive it up there. Post message, same deal, we're going to call it here, we're going to receive it up there. Post members and put members, same thing. We're going to post them here, put them here, and receive them up here. This way we can receive other people's messages, pools, or members, or additional memberships, and we can actually keep everybody in sync without anybody having stale data. So here we have our user data. We're going to call the user service on the back end, and we're going to store the user. We're also going to store a comparer so we can see if we need to update the user. And we're also going to grab all the users from the back end so we know who we can message. And this is injectable into any class that we want to use. So we're going to call get user with the authorization ID. We're going to call the service get your user, and we're going to set the user. We're going to set the comparer, and we're going to tell whatever class called this whether it succeeded or it didn't. Get all users, we're just going to call get all users and new up a new user array, loop through the array of users that have passed to us, and just new up a new user into this users array, and then assign it to all users. Put user, we're going to take the user that we currently have set, and we're going to update it, and we're going to go ahead and update the existing user. And the compare, we're just going to go ahead and new it up and send the new object values into the compare. And post your user, we're going to do the same thing, except we're going to be calling the post, and we're going to update the user, and we're going to new up this user. And really you just want to update this because you may get a little flicker if you have new users. It'll kind of reload a page. So this update just kind of updates the values, and it doesn't cause any page refresh or any reloads. All right, it's now time for our view. So the entry point for the web for the view is this index.html. Just a couple highlights. We have our title set here, which you see up here. We have the base class, which is basically the current folder. We have a link and a script for Bootstrap 5. I have a tutorial on that, how to start it quickly. It's very easy, or you can go to the Bootstrap 5 quick start page to see how to do this. We are adding a container, which is a class on Bootstrap. And once again, I have tutorials on Bootstrap. If you'd like to see how this works, I kind of go through all the little details about how it's structured and what you can do with it. This app root is the initial starter class, which is this class right here, or sorry, starter component. So this app component here is where it starts, and we can tell that by the selector ID here, app root. And right here we have a nav bar, which is currently hidden. We'll show you that in a second. And we have this router outlet, which allows you, based upon the route, to load different pages. And we define those pages in this app routing module. So the root path is this home page component. We have a messages path, which is a message controller component, and a users path, which uses the users component. And those are the initial page loads. So we'll show those right now. So here is our home page component. This home page component is taking up 12 columns of the grid. It's spanning end to end. It has a little bit of padding here because of the container that we put on index here. And we're using a row that actually takes out some of the padding here. We push it over to the edge, but then we reintroduce it with all these columns. So by default, we're starting out with a column of 3 and then a column of 9 whenever it's small. And then whenever we expand to the medium size, we do half and half. So that's kind of what's going on there with the sizing. We have a bigger font size for this super awesome website text. And we're injecting this app login component right here. And on the back end, we're not really doing much. We don't have to in this particular page. And we don't have anything else in our back end CSS. So this is just a simple component, really just to give us a little separation between this component and just this text right here. All right, next up is our login view. So at the top of it, we're going to do a 12 grid column, and then we're going to add a row. I always like starting out this way with the 12 grid column. That gives us consistent spacing and to make sure it goes end to end. Sometimes if you just start out with a row, it'll only go as far as it needs to create all these elements, and then you'll get some weird padding on the side. So we always start out with a 12 column grid row. The row will actually take out the spacing from the 12 column grid, but it'll force it to go end to end. So I always like to start out with this pattern for all of my components. And the next, we're going to add an email, which will, the column grid of 12 will actually add some spacing into the row. So we're going to contain this together, and we're going to add an input group. And we're going to add this input group text to get this effect here. And this will actually force the spacing to be left to right and smushed up together and have this little gray effect with all of this bordering that you see here. And for the input group, we're going to use a form control class to get the styling for this control here. It's going to be type text, and we're going to bind to the login DTO username. And this ng model, in order to get this to work, you're going to need to add this forms module onto app module. And there's a few other things. You'll need the HTTP for API. You should have these additions already added by default. So back to the HTML. So the next one is the password. So we have, once again, an input group for this password. We have the form control component. We're binding to the login.password, and we're using this for entering your password and for the password reset. So we have some effects here. Let's just kind of show you what's going on. If we type in test@test.com and click reset, we should see this server's waking up. We should see the new password come up. That was the first hit to the server, so it took a second. So basically what we're doing here is we're doing string interpolation. If we have password reset, if we have the password reset token right here and we don't have a password set, we're going to turn this password text right here to red using text danger, which is kind of their red color for Bootstrap. And then we got a little bit of spacing right there. And then we're flipping around, we're doing new password if there's the password reset token passed in. And we're also doing a form control for this input element with a password type, so that way you get this these little asterisks here as opposed to the actual text, and then binding to the login.password. So the next one here, we have a display name. This is currently hidden, so we're only turning this on if it has no name. So if we do, let's see, we'll do register, new user, we'll do test. All right. Let's type this in, testing.1, register. So the first time you do register, I just have a toggle flipped is no name. Once again, we're doing an input group for this with the display name, input group text to get this effect. and then form control here of type text. And we're binding just to a backend property in the TypeScript file called name. So this right here will get us, we'll turn this display name on, and then when we click confirm, once we type in this test name, we can click confirm and it will complete the registration. And this is going to be used to create the user out of the box so that you have some user with some name so you can look through the list of users to message. So that's that point. So the other one is code. We saw that a second ago. So if we do test.com, we do a password reset, faster there the second time. Then we're going to get this code element here, once again using the input group test, and only when this password reset is set to something. Right now it's an empty, well, not right now, but before it was an empty string. Now we set it to this big long code right here, and that's what turns this on. And we're just a type of text, and we're doing ng model of password reset. So we don't need two-way binding in this case. We're just doing it one way. This is the setter, where the parentheses would be kind of a getter. So basically it's received from something else first being set. So the next set of lines here are all of our buttons. So we're doing a column of 12, and then we're doing a row, and that takes out the spacing. And then we're doing a column of 3 for this reset here, and a column of 9 for everything that goes over here. And I just tested this on the spacing for various sizes to make sure that everything looked well. So just going through this, by default, we're going to have the password reset. And as long as the password reset isn't hit, then you'll see the reset will be there. But if the password reset comes on, we'll basically get rid of it. So in order to get this styled correctly, we need to add the button class, which is a Bootstrap class, to get a better looking button. You'll see if I take it out, it won't look quite as good. Let this compile. And while that's compiling, see how this has this little box here? We don't like that, so we're going to turn that back in, and that box will go away. So we're going to style it just with simple coloring, as opposed to, we could do button warning, which would give you a kind of a highlighted button. I like this kind of flat look and feel personally. So we're taking, these are just margin spacing, and you can look more at this in my Bootstrap, but this is margin start of 0, padding start of 0, top bottom for my of 1 for margin, and then margin of the end has the spacing of 1. So this is just a little bit of spacing, and we push the text to the left in case there's any weirdities. It'll push it over to the left. This column 9 has text in, so it's going to take column, basically everything from here to here, push everything to the far end. And by default, we have this login and this register created right now. So the login, if there is no password reset, we're going to have both of these showing up here. If the password reset comes in, we'll show you that, test.com, then that's going to go away. So that's how we have everything here. We have the click event binded to some methods in the back end to post your login and post the registration. The first time we do registration, we'll toggle an is no name, and that'll turn this into confirm. And I'll have to take off this since it's already registered. I'll do this. So we register. First time it does the hit is no name, turns this into the confirm button, and then adds this cancel if there is no name. And then we just set the click button is no name to false if we want to cancel this to get rid of this. So that's kind of how those work on the front end. And this is the password reset as we shown before. So we have a post password or a cancel if we're going to do a password reset. This is only visible if the password reset is set. It actually has a value, sorry. And right now these are just blue color text primary, and text warning is kind of a yellowish orangish color. Primary is the blue color here. And you can do button primary. Let's show you that real quick just to show you what that looks like. It's just a different effect. I didn't personally prefer it. So, oh, sorry, the wrong one. Let's do it to this one, button primary. So I didn't like that look and feel, so I was going to do text instead. So I like this a little bit better. So basically go, so if we're going to do cancel, we're going to get rid of the password reset. We're going to basically clear. We have some errors we're going to show you in 1 second to finish this up. So we're basically going to reset everything. And then we have some methods in the back end. We'll show you the Typescript file in a second. So down here at the bottom, we have some error message. So if you have a reset error, then you can enter your name or reset your password. If you have registration error, we pop this. We basically have a flag on the back end, and we'll show you the Typescript in a second. And it adds this message, turns it red, so that people can kind of see that you have an issue, and it kind of points them in the direction of what they need to do. So actually, I should probably call this, instead of username, we should call this email. This would be better, since I originally called it username, but then I decided to change it to email just to better identify. So I kind of like simple messages so people know exactly what to do. So include both email and password. You see email, password, reset, enter your email to reset password. So this is kind of more explicit on, hey, do this. You kind of assume people know how to work with these things. You don't want to give them big long verbiage, because then they have to read the whole thing, and that kind of annoys people. So just basically direct and to the point about what you want them to change. All right, next up is the login components Typescript file. So this is what we're looking at here. We have app login for the selector name. We're starting out newing up a login DTO to do the backing for the email and the password. We have some is reset error, is reg error. We're going to default these to false. We have that is no name we talked about earlier, and the name property defaulted to nothing. We're injecting our auth data, which, as you saw in a previous video, combines our services and our models together to store the identity user data, which combines our user service and our user model to store the user data, and this navigation function that goes through and changes us to different windows, the 3 different routes that we have. So on initialization, we're just going to reset all these values just in case. So we'll show you that function. It's down at the bottom here. So it just turns the reset error off. It basically turns the errors off, does a new login DTO, does a password reset. It's just kind of a way to clean up, real kind of cheap and easy. And on initialization, we're going to check if we logged out on this authorization in our navigation. We're going to hook into this is logout function. That way, when we log out and we go through this initialization, it's going to check our login and see if we're already logged in, and then automatically log us in. And we don't want to do that if we purposely went to this login page, if we logged out, basically. So it's going to check the login. It's going to get a login view model if it's successful. It's going to have an identity user. It's going to have the token. And if this is true, then it's going to determine that it's logged in. If false, it's going to determine it's not. And we're going to check if we're already on the navigation's current route, because we don't want to reload that page again. And if we're not, then we're going to go ahead and move to the message page if this is successful. If it's not successful, we're going to stay on the home page. If we're already on the home page, we don't want to do this. So the next one up is our post login. We're going to reset all our errors, just in case we did registration first, got an error, and then login. We don't want this to be popped up here as we click login. Let's say we get a bad registration, then a bad login. We're going to have both of these messages up. That won't look very good. So we're going to check if we don't have a login or a password. And if it is, then we have a registration error, which has the same message that we wanted for the post login. So I guess, sorry, this would be for the password reset error. You didn't want both of those up. So that's what's going on here as we pop up this message, which is the same for registration or login if you don't have everything. We just need email and password for both cases. So when we run through the login, we pass in the login DTO, we get a true or false. If it's true, we're logged in. We have the values already stored in this authorization data. So we go ahead and reset the values, and we go to the message screen, which is the next screen up for us once we log in. Post-registration, very similar. We're resetting the errors. We're checking for the errors, and if there is an error, we're going to turn it on, and then we're going to return. If there isn't a name on the post-registration, then we're going to toggle the is no name to true, and then we're going to return. And then if all of that's true, we're going to come through here, we'll have the name, we won't have an error, and we're going to go ahead and post registration with the login DTO, returning if it's true. Then we're gonna go ahead and log the user in. We're going to create a user. We're going to add the name, auth ID. We're going to post the user, reset value, and then go to the message screen. This way we do our registration, we add a user with the name that was the display name we showed earlier, and we go ahead and save that so you have a user by default. So reset is reset password. Once again, we're going to turn all the errors off. We're going to check if you have a username. If you don't have a username, then we're going to turn the is reset error on and then return. Otherwise, we're going to pass the get password reset, and this is going to store the password reset token or password reset code on the authorization service. So if we post reset, we're going to turn the reset error off. I need to do the reg error off here too also. And we're going to check if the user has a username and a login. And if not, then we're going to do the reset error. Then we're going to build the password reset DTO with the username from the login DTO, the password code from the authorization data class into this code object. Then we're going to go ahead and post password reset. This should, if it's successful, it's going to build our login model. It's going to reset all the values, and then we're going to go to the messenger service. So that in a nutshell is what's going on. All of these methods, so post reset is bound up here. We have this reset, which you see is somewhere. Reset is right here. We have our post registration and post login. So you see login and post registration. I think that's it. Yeah. So that's it. So that's basically how we bind all these elements from the front end to the TypeScript model. We do manipulation. From that manipulation, we can change the state with ngIfs. We have string interpolation going on up here for some styling and for some adding a new word here for the new password. So that's kind of how we interact between the HTML and the TypeScript file in order to drive this component to do a bunch of different changes based upon our interactions. So now we're ready to log in. So let's go ahead and click our login. So we're now logged in, and the first thing we're going to talk about is this nav bar right here that we can interact with. So here is our nav bar. So by default, if it's on the home page, we're going to hide it. That's why you didn't see it before. It was just the easiest way for me to get rid of it on the home page. In order to get this to work, we need a nav bar dark, background dark. That'll get this styling. If we want this little toggler button, we have to do the expand size. So you have to determine what size it expands at. So this is basically on a small size. We're going to add this toggler button. And we also did a row to get to basically make everything go end to end. And because on the index file we have a container, a row with a parent class of a container will stretch end to end. So that's why this is going to work. And I wasn't worried about putting a column 12 and then a row in there. So that's why we use the row to get this to expand to the very edge. The next object up is just a container fluid to make sure that all of these items go to the very end of this inner container. The first anchor tag here is a nav brand. That's what it looks like here. So this nav brand is just styling from Bootstrap that I used. We did a little bit of spacing here because of the sizing to get it pushed up just a little bit to be in line with everything else. And if we're home, then, well, this actually is not necessary anymore. So when I had this originally on the home, so I should take this out. But this isn't going to be visible on the home. But basically, if you click on this, you're going to be logged out. And it's going to go use the navigation, and we injected navigation in the nav bar, and we're going to do home press, and that's going to go to the home page. And the next thing up is this button with a toggler, so that's what this toggler is, and we'll show you what happens if we expand it out. It goes away, and if we expand below a small size, so I just did this kind of spacing and making sure that everything looked well, and if it could go kind of small, so I want it to be as small as possible, so that once you get to small size, it pops on. And basically how it works, you pop this and you can go to the different pages here. So we click on this, or here, we can just click between the two. So that's kind of how that works. So that toggler is part of this Bootstrap's navigation component. You need this nav toggler. You need a bunch of these things in order to get it to work. I have a whole little video on how to use the nav bar. Feel free to go look at that for some more detail. We're just going to hit on the Angular topics here. We'll need this collapsible nav bar in order to get this to work correctly between the two. Once again, this is more of a Bootstrap thing, so go ahead and look at that. We have this nav bar, once again, Bootstrap, so you can look at the details there. We have each of these linked for messages and profile. We're turning these bold if they're on, so you can see this is bold and not. This is just kind of a way to tell the user that that's the page you're on. I could have done underline or something else to kind of show them that you're on that page. Just kind of do whatever you like to get the right look and feel that you're going for. And on this anchor tag, on this button, we're doing navigation message press for message and home press for the profile. We're also doing this toggler button. So this toggler, we're binding to this pound toggler right here. And basically this is a way that once we click on this, like let's say it's expanded, under normal conditions, this won't close. So you click on message or you click on profile here, this whole thing will stay open. You'll see the message and profile. I didn't like that effect. So I added the toggler here, and I did a click, since you can basically add items to the DOM that basically identify what it is, and you can act off of some of the methods that are available to it. So in this case, this is a button. It has the click event available. So if we click on it, it's basically going to act like we clicked on it here. So we wanted to collapse it automatically when we clicked on messages. So that's why this is here. So let's look in the back end to see what's going on. So our navbar TypeScript file is very simple. We're just injecting the navigation service, the authorization data service, and we are just, the other thing to note is we have this app navbar selector, and we're putting it here on the root application component, and the app navbar is above the router outlet. That's why we had this is home, not true. That's why you don't see it on the login page. So that's all there is to the TypeScript file for the navbar. So here is our message control. And this, for the message route, is the entry point. We can check that on the routes, messages, message control component. So here is our HTML. We'll just go over this real quick. Once again, we spanned it column 12 to the edge. We added the row. We added a column of 4. And normally this would add spacing. So we took out a little bit of the spacing, margin start, padding start of 0. We have a div tag here and with the small no messages. If there are no messages, I've added some messages here. So this would show up if there were no messages. So data.pools.length equals 0. If that's true, no messages. If not, we're going to give a list of pools. And this is a property in the back end. I sorted all the pools to be reversed order. So basically, the last in is at the top. That's what this does. We'll show you this in a bit. So each one of these are a button. It has a border around it. Blue text spanning the whole length of the width of this 4-column side. Otherwise, it would only take up as much space as it needs. So we did column 12. And we put a margin on the bottom of 2. And that should give us some spacing here too, so we can easily see which item we want to click on. And here we have a selected pools. In this selected pool, when we click on it, it will actually select this pool and give us the data so we can add new messages onto it. Or we have a new pool here. So we toggle between selected pool, turning this on, or new pool equal null if we click on this. And then we do some work down here to have the new and everything else. Basically, this is a pool object right here. As you see here, our app pools. This is the other side of it. We have a column span of 4, column span of 8 for everything here. And we took out all the padding on the column over here just to get a nicer look to it. I just kind of liked it when it was spanning to the edges there personally. So that's why I did that. Now, if you're a new pool, and by default I start this page out with the new pool, then this is what the new pool looks like, and you can add multiple users. If not, we need a selected pool. So if we select a pool, we're going to turn the new pool off, and we're going to select the pool, and that's what you get here is the selected pool. So that is basically what we're doing here. We have the selected pool binded to this pool object here, and we're going to pass it into the pool. We'll show you the pool in a little bit. We have a new pool binded to this pool, and we basically flip between the two. And we have some methods here to take an output event of new hit, and that is to create a new pool. So it'll create a new one of these pools, and it'll turn the selected pool into null. So it'll basically get rid of the selected pool. And that is more or less how we're styling this top level component. It's basically going to control the lower level components and just give us kind of the look and feel that we want, basically the more or less the shell of how the message service is going to look. So here we have the message control TypeScript file. So here's our message control component. We're adding a new pool, a selected pool, and ordered pools. So we're doing orders by going to the pool data here, which is the message service plus the pool model. And we're sorting that, and we're going to return a sorted array. And basically how we're doing this is we're using the created time of the model. We're newing up a date, and we're going to call the getTime function off of this date. And then we're going to subtract it from the previous date. So if you want to get a sorted order of the most recent first, take the second item, new a date, get time, minus the first item, get time. And this is just going to give you a time since the epoch time. And basically if this is positive, it's going to go above, and if it's negative, it's going to go below. So that's how that works. But we're injecting the pool data, as we said, the authorization data for the identity user and identity user model and the identity service. We have our user data, which is our user service plus our user model, and then the navigation service for navigating. And this is just a guard check on initialization. If for any reason we don't have this authorization data set, we need to go back to the home page. That's just a guard check. And on initialization, we call the get pools, passing in the auth ID, and that's going to get us all the pools that we're a member of. We're going to pull and get all the users, so we have a list of users here, and we're going to create a pool. So on initialization, we're going to check if we have a pool, which we shouldn't have a pool. It should be null. And if it's null, then we're going to add a new pool, add a new member, set ourselves as the member, push ourselves as the new pool member, and that way we can save this later with you as a default user. So the get member names, this is actually going to be used on our button. We're just doing a simple concatenation here of all the pool members that you're basically passed in. So these are all these pool members. So we're concatenating all the auth IDs, and then we're flattening this array so that's just a list of auth IDs. And so it's looping through all these auth IDs. It's pulling back the array of users that it finds from all users. And then we're doing the same kind of flattening out of this array of users, just pulling out the names on the user. And then we're using the join function to split them up into name / name / name. So these should have all the names going through here. This could get pretty big. We should probably look at this in terms of the styling, because on the button here it's just a list of member names, and this could get long. So this may be something to look at and make sure that there's kind of like basically an overflow with no view of that. So you can just have all the names listed out here and then cut it off for where you don't want to show it, or you could just wrap this. There's a few things we could do here. But that more or less is what we're doing on the message control. We're getting the data, we're getting all the values that we need, kind of the initialization of all the messaging services is going on here. And then we're going to do a lot of our work in the pool, and there's a little bit of work in the messages in order to get all this tied together and to work correctly. So let's go over our pool component. Our pool component has a column span of 12, so it's spanning the length of the control that it's placed in. And we do a row, align center, to get this spacing that we're going to need for these next two div tags. So if the pool is new, we're going to span the whole length. If we're not new, basically if we have one of these selected, we're only going to span a column of 9, and we're going to have a new button here that we can use in order to create a new component. So we click on that, we're back to new. We're spanning a column of 12 or 9. We're going to use a drop-down control here so we can get some prettier effects on the button. So we have an image and some text here. As you can see, we have an image tag that is just spanning a column length of 2. And then the text here is spanning a column length of 10. You have different font sizes for those two. And we have basically they're stacked on top of one another. And we have some overflow hidden tag class right here. This is a Bootstrap class. Basically, if it runs off to the edge, it's just not going to wrap it. It's just going to basically not show it if it gets too big for this text, which is set to a max height of 50. So if it gets higher than 50, it's not going to show this. So that's kind of how that's styled. This drop-down class, I have a video on how to do a drop-down, but basically you need to do the drop-down toggle, a drop-down menu. We put a max height on this because if there's a bunch of users, you don't want this to be too big. And then when we click on this, we add a new user to our message, to our pool. So if we add a user, we have a list of members down here, and we're going to loop through the members, and we're going to give it a little bit of styling. So we're going to the full span here. I could have done column 12, but we have a row that's going end to end, and then we're putting a basically full length column right here. We're doing an input group. We made the input group small just so this looks a little smaller than it would be without. And we're going to add initially a column span of an image. And we're going to add this with input group text. And then we're going to dump our image tag in here. We're going through with the authorization ID of the member. And we're going to look at the user data. And from this method right here, we're going to grab the file attribute from the avatar class in order to dump in the source. This is a base64 string. We'll show you how that works later. We have a max size of 30 pixels. So this fits right in this box. And we have an input class that we set, and it's not two-way binding, just single setter binding. And we disable this. It's the best way I had to get this look and feel that I wanted here. And then we have a button that is X'd out, and we're using the button danger property to add it at the very end. And this input group helps style this whole look and feel, basically keep everything together. So you have this little grouping of controls. And if this is your user, we disable it if it's yourself, because obviously we need at least one person here, and we know you're going to be part of the message, because why send a message that you're not involved in? And we only show up if this is a new pool. So pool ID equals 0, then we can X out. Otherwise, we're just going to show the list of users to say these are the users that are currently in the group. Currently, right now, I don't have a way of getting rid of group members that are already in there. We could always add that later. So if you have more than one group member, by default, you'll have one group member yourself. So if you have more than that, then we're going to have this add a message to the group. And if you do that, we are going to call this class add message in the TypeScript file to add a new message. So you'll see here, we're going to add this new message. We're going to bind to this message property. So this will be a message type. And when we send the message, we're going to handle the sending on this pool object. And if we cancel, we're going to get rid of this message. And we're going to have a set of ordered messages, basically newest at the very top. And we're going to basically give you the message text right here. And then we're going to say who it's sent from. So we do test, we do send, then you'll see this is the message, and it came from test. So that's how the pool HTML works. We'll look at the back end, and we'll kind of map some of these things so you see what's going on between the TypeScript and the HTML file. So now let's go over the pool component. We're going to have an output event, a new hit, anytime we're creating a new pool. And we have the new hit here for the new button. In case we have a selected pool, we can click new. We are inputting our pool element from, or our pool model from an external class, in this case, message control. We have a new message to store when you're creating a new message before you send it. We have a list of members on this pool and filtered by which ones aren't deleted. We have a set of ordered messages. So basically we're going to get the messages on the pool and we're going to sort them, and the last in should be at the top. And we discussed this before, but we're going to use the created date time, and we're going to new up a date and to get the get time function, which will get your time in milliseconds, and we're going to subtract that from the first value. So in order to sort by newest in is at the top, we want to do the second minus the first. Get other users. We're going to loop through the all data property on data, and this is our user data, and we're going to filter based upon whether it's not deleted and whether the members are not in your list of members for the pool. So if we add a member, we don't want to see that member in there again. It would be kind of irrelevant to have that member in there twice. It would confuse people. So this is how we loop through all these members and get other members to make sure that we are not inserting the same member twice. In our constructor, we're injecting user data. Once again, this is the user service with the user model, authorization data, identity service to the identity user model, pool data, which is the message service to the pool data. And get username. So we're going to pass in an auth ID, and we had this over here. Where was this at? So we had this at the very bottom for our messages, and we added one more place. Whenever we're looping through our members, we will see the username. So that's how we're going to pull the username, just by using an auth ID string from using the data.allUsers class or array on this class. Get user image, very similar. We're going to look in our users. We're going to find the user, make sure it has an actual image, and if it does have an image, it'll be because we newed up this class, this avatar class, and we added a file. If not, we're going to return null. That way it'll know not to show an image. Add user. We're going to pass in the user that we click from here, and we're going to add the member with the auth ID set to the member, and then we're going to add this to the pool. Add message. We're going to call this to just new up a message, and we're going to define who it's from, which in case is always going to be the person that's creating the message, which will be yourself. So that's where we're using the authorization ID. So this is going to be the string ID on the auth identity user. And send message, we're going to have two cases. If this is new, we're going to push the message onto the pool. We're going to subscribe to the pool hit. This is going to be our socket, and this way we can kind of synchronize this message once it's saved. And then we're going to post the pool data, and when it comes back, it's going to resolve the pool data to the list of pools in your pool data class. So you'll get them synchronized up here, but you're also going to get the current state of this model right here. So if you do any updates on the message, you'll have the ID of the pool when you save it. So that's what we'll do here. If we're an existing pool, we'll have a new message. We'll set the pool ID, since we'll need to have the pool ID set on the message in order for this to save correctly, because it has to know what its parent is. Otherwise, it'll fail. And then we'll post the message, and that message will come back. It'll be resolved through the WebSockets, and we'll see it on the list of items here because we're pulling through a list of messages, ordered messages. So we're pulling through these ordered messages here, which is on this list of pool, this pool that we have loaded in here, and the pool service is going to find that pool, add or update, or in this case, add the message onto this pool. So that's more or less how this works. We're going to be linking these functions to the pool objects here, and we're going to be calling them and then saving them, and then letting the WebSocket return back the data, resolving the data, and ordering not only this list here, but updating the object that you have here. So let's look at our message control HTML. It's a very simple control. We use a text area control, and we're going to style it with the form control from Bootstrap. we're going to have a send and a cancel. We're basically going to extend through the whole width, and we're going to take out any padding on the side just to get everything lined up here. And we're going to push the text to the very end, so that's why it's pushed over here to the right. We're going to add a couple buttons. We have our button text primary, which is why it's blue, and text warning, which is why it's more of a orangish, yellowish, golden kind of color. And on each of these click events, we're going to output a couple events. So we got a send hit dot emit equal true, and a cancel hit dot emit equal true. And we will bind to these in the pool object right here. We have our send hit and our cancel hit. So that's how we link these methods together. And of course, this is going to call other functionality that we're going to use to change the state, either send the message or just get rid of it. And in the Typescript file for the message control, it's very simple. We just have the send hit output event and cancel hit output event, both resolved to true or false. And we are inputting the message from the external control. So in this case, we would send the new message in that we would use in order to populate this message right here. So that's what we have for the TypeScript model. Very, very simple. All right, let's have a look at the user component. So at the top here, we're going to build out our 12-column grid row to space everything end to end. We're going to add a row. We're going to add a sticky class, which we actually added in the SCSS. This basically just, when we scroll down, this element up here, the update profile and edit to save, will be kind of bound to the top. That way, if you make some changes down here and you scroll down, then this will scroll basically at the very top of the screen so you can save it very easily. So we're going to just split this column up in half, one with update your profile, the other one with the button that is going to save the user data. So we're going to check using our deep equal whether or not this needs to be updated. If it doesn't need to be updated, it is disabled. And we have a check here for need update, and it'll either save your changes, which it's not doing right now, or edit to save. So right now it does not need an update, so it has this edit to save option right here, and we're disabled. The next line is going to be everything right here. So this row is going to have a couple elements, the name, the birth date, and the profile. We're going to put everything in these input groups, and we're going to add this input group text field for the name so that we get this little effect right here. We're changing this. Let's say we space this out. Let's go back to this. If we spread this out over here, we can see that we're basically grouping this into a side of 6 and a side of 6 if we go belong medium size. And that way we can kind of have a little better look when we have a wider screen. If we have a small screen, then we're going to put it up and above one another so we have enough room to enter whatever data we need to enter here. So all these are going to have the input group text. So we get this effect. Same thing here with the profile. So for our inputs, we're going to use a form control, and this is just binding to the user that is in data, which is going to be the user data class, and then we're going to bind to the name here. Birth date, we are doing this a little bit different. We're going to use a date time control class, but because this returns things as a string, we're going to need to do a little bit different. Basically, we're going to set through the ng model the birth date, and we're going to style it based upon, or do a pipe for the date formatting to be 4 days of the year, 2 days of the month, or 2 numbers in the month and 2 in the day. And this is the format that this date time prefers. And then when we change it, we're going to call a method that's actually going to new up a new date, because this sets it as a string in our object model backing the birth date as a type of date. So we need to force it to be a date. Basically, that's why we're doing this, and we'll show you that method in a sec. And this event is just the value that comes from this input control, which, like we said, is a string. Profile uses a text area, and just like the input, you can add this input group text, and it fills everything else out nicely right here, and it finds everything to the side. That way you can see what's what, and it's a very clean, nice look. We set the rows to 3 so that it's a little bit bigger than normal, and we default to form control so that we get this styling here. And then we're going to bind to the profile data on the user data control, the user model on the user data control. So the next up, we have our file. So this is pretty simple here. We have a file type input element with form control. We're going to limit what we accept, just PNG, JPEG, or JPG or JPEG. And we're going to hook into the change event of this input control, and we're going to add the file from the event. And we'll show you how to add the file and convert it to a base 64 string so that you can store it in this avatar file class. So if we have an avatar file class as we do here, and as you see real quickly, I can change things around. Then we're going to set this to the source. This base 64 string will be read as an image, and it'll output the image to this area right here. And we're going to make sure that we have a max height of 250 so this doesn't get way too big. Next up, we have this card control. We're using this to create a little bit of styling break here so you can add your contacts. So we just did this for look and feel. This is one of the Bootstrap controls. You can look and see how to build a card. I have some videos on that if you want to look at that and go into a little bit more detail. But basically at the top end, we're going to have a card. We're going to have a header that's right here. Normally it's a little grayer. I didn't like the look, so I wanted to match the look to these values. So I found I basically looked in the back-end style to see what color this was, and then I just made the color, this background color, the same type so that this looks the same as all of this, so there's consistency. And then we did your name, add your contact. We added our body here, and we have a button where we can either create or cancel. And if we're creating, we have a new contact. So we added the app contact class, which we'll go over in a second, and then enter a new contact. And then if we make changes, make additions, we can do add. And as you see here, this is just our save changes kind of sticking to the top here. That way the user doesn't have to scroll all the way to the top to save the change. Plus it's a little bit more obvious that they actually have to make a save change because your user might not realize, hey, I made these changes. Now I have to force the update. We want the users to update this every time. So that's why we're doing that. So below here, we have this footer. In this footer, we're just looking at a context property on the back end. This is just a list of valid contacts that aren't deleted because we could easily delete these. And so it looks for the valid number of contacts and counts it just so you know how many contacts that you've created. So below that, if this contacts class has more than 0 in it, we're going to do this again. We're going to have your existing contacts, and we're going to make it bold so people can tell that it's there. And then we're going to basically loop through all those contacts, and we're going to display them with a little bit of spacing. And this is one of the reasons we had this MB4 and PB4, just because it was kind of tucked in really close there to the bottom, and it was hard to tell it was there. So this gives it a little bit more spacing, a little bit more padding, so your user can tell that there's actually something down there. So, all right, so let's go look at the TypeScript class. So let's go over the user components TypeScript class. So on this class, we're going to add a new contact of type contact, start out null, just a simple helper method to get the authorization ID. Our needs update is going to take our model helper class and run our deep equal command, choosing the user and then the comparer object, which is just a newed up user whenever we grab the user. So if we make any changes between these two, any of the properties, it's going to be able to tell, and it'll tell us that this is true, and this will ungray this out, and we're also going to have the different text on there so that we know to save the changes. Contacts is just a filter list of contacts off the user that aren't deleted, so we could add a contact here and then delete it. We don't want to return those ones that are deleted. We're injecting our user data, which is our user service, with our user model, auth data, which is our identity service with our identity user model, the model helper class, which is just one of our helpers, and the navigation, which is another one of our helpers for navigation purposes. And on initialization, we're going to make sure that we have the user, so we're going to grab that by auth ID, and that's going to be set on the back end, and we're going to grab that from the data.user class, so we don't need to store it anywhere. We have our set date method for our birth date right here, so this is going to come over as a string. We're going to new up a date based upon that string, set it to the birth date. Add contacts, this is going to be a toggle. If we don't have a new contact, we're going to create a new contact, go ahead and assign our user ID. We should already have a user with an ID set, so we'll just go ahead and set this, and then we can add the data in the class that we create below this contact class here. And if we hit it again, we're going to add this to the contacts of the user, and then we'll have a difference here, so we'll know that we need to save it, and then we're going to null the new contact. Add file. This is from the file image, which is down here. So we're going to take the change event, which is going to come over as an event. We're going to grab off the target, and we're going to do a null check. Off the target, we're going to grab files, and we're going to cast it to a file list. And we're going to new up an image at this time. We're going to use the file reader class to read this data as URL. So we're just going to call this method, pass in the first index of the file. Since this is going to be just one file at a time, not multiple select files, this will work for us. So we just want to add one. And then on load, we're going to just basically take the results of the file, which will be a base 64 string, and assign it to file. And we're going to need to bind to this in order to get the data for this .data in this particular case. Otherwise, it's going to assume that it's binding to the reader event, and we don't want that because we'll lose the scoping for this data object, which we pass in to the constructor. So this is all that we need on the user backend to get everything to work. Everything else we've done, for example, we had a cancel here on the contact. We just did new contact equal null if we're going to hit the cancel here. So it's not running into the back end. So you can do some stuff on the front end, some stuff on the back end, it's kind of a preference issue. You don't really want to create a method just to do new contact equal null, so might as well do it here. So let's go over our contact component. So starting out, we're going to stretch it across end to end using our column 12. And then we're going to do a row so that we can get everything in line. And we're going to have different sizes based upon the screen resolution. So by default, we're going to, or at least on the smaller screens or anything smaller than a medium, we're going to do full width for the contact class. We're going to do almost full width for the input group. We're going to have a little bit of space for a button here. So that's why we're doing column 11 and column 1. Right here, if we're a medium-sized screen, if we expand this out a little bit, we can see that we go in line with our object here. So we have a contact and we have the type over here expanded out. Same thing here on the new. Let's expand that in a little bit. So we're doing the input group for the contact, and that's going to give us this effect with the input group text, and then we're just doing a text type over here binding to the contact class's link. The next one, we have a select class with a bunch of options. Once again, we're also doing an input group, and we're doing an input group text to have this little type thing right here. And then we have these list of values, which are all strings that are going to be bound to this string type on the contact class. If we're adding, and we'll do this one first, we're going to check if we have both the link and both the type, and we're going to have a text primary. If it is if we don't have this, then it's going to be grayed out. As you see here, we can't add it, but it'll be ungrayed if we actually add our values in here. And we're going to input whether or not this is new or not. So this is going to come from the user class, so we're actually going to input this is new, whether or not it's a new class up here or an existing class down here, because it may not be saved. So we don't want to have this add value down here. So that's basically what would happen if we had not saved the contact and we added it and we just went off the ID. So we're going to tell whether or not it's up here or down here based upon the user component class. That's going to tell us whether it's new or not. So if it's not new, then we're going to have this X button down here, which we can use at any time. There's no disable. It's using the text danger with the button. And we're just going to go ahead and delete it. So we're going to set the contact item to is deleted equal true, if that's the case, and then it'll go away. So that's how the contact class is working. Let's go see the Typescript class. So our contact class, our Typescript class, is very simple. We're just going to have a save hit event that we can add, and we're going to call it when we have this hit this add class. And let's see where we have this up here. So on the user we're going to have our save hit up here. So whenever we're doing a new contact and we do the save hit, we're going to call the add contacts again. Remember, this toggles between creating a new one or saving the existing one. So that's how we're going to hook into that. And we're going to pass in a contact, and we're going to pass in whether or not it is new or not. So we're going to do that from the user. So the new contacts, it's always going to be new. And then this is going to default to false, so we don't have to set anything here. For the other contacts, if it's false, then we'll know that this contact class is false, and we can handle these buttons appropriately. So that's a very simple class, and that's it for the contact.